My name is Juan Jose. We are at ENSTA-PARIS. We are 9 PhD students that we are integrating all of our research in terms of robotics, computer vision, and manipulation skills. We are working with 3 different robotic platforms, 1 leg robot, 1 drone, and 1 manipulator in a mobile base. First one that I would like to introduce you is the Unit3 Go 2 in charge of Chanda.
Hi everyone, my name is Chanda. I'm working on the legged robot called Unit3 Go 2. We have developed an autonomous navigation system for the robot, so the robot can autonomously run in an unknown environment.
We use our leg robot, the Unit3 Go 2, to explore and mapping the whole area in a teleoperation way and an autonomous way to get into the valve. Our second robotic platform is a drone built by our friend Sasanka.
The main task of the drone is to do the surveillance and mapping. So as you can see here, we have the camera, which is here, and the LiDAR, which does the mapping, which we are planning to send the mapping details to the robot dog to do the exploration and retrieval or the manipulation of the valve.
Hello everyone, I'm Hai Chuan. This is my current research is related to the multi-robot perception system, and especially it's for a collaborative perception. And what we should do is that we use different robotics to generate their own local map, and after that we use our algorithm to combine all the local maps together so that we will get a global map.
Finally, we have our third robotic platform that is a mobile manipulator, our UR5, that is in charge of our 2 friends, Sahar and Yifeng.
I am Yifeng, my friend. We are working on manipulation, the autonomous manipulation. We have something like the point-to-point navigation control.
So we are going to use a UR5 to control and turn off the valve. How we are going to detect the valve and the pose estimation? We are going to use an Intel camera with depth detection, and the pose estimation and pose detection is going to be explained by our friend Hemi Dresa.
Hello. My duty here was to detect the valve, as you can see here, and to define its position in the camera frame so that it can be used with the LiDAR for localization in collaboration with Sasanka.
Hi, I'm Alessandro Melone, and here I'm working on the valve pose estimation. And as you can see here, this is on orbit, where you can see the bounding box of the valve detected, and you can see also the axis that describing the valve pose. And this task is important such that we can then do autonomous manipulation and grasp the valve and do autonomous turning of the valve.
Of course, this wouldn't be possible without all the mechanical design and all the mechanical setup for our experiment. For that, here is our friend Alperen.
It's Alperen. So I designed the 3D parts to be mounted on the end effector and to hold the valve in place. So we have like a camera mount that we designed for the end effector and specifically the camera. You can adjust it and it gives you the sensation of you are seeing from the POV of the robotic manipulator.
Hello everyone, my name is Ethan Tong. I'm responsible for the control program of the Husky robot with the UR5 manipulator. Once I receive the detection information from the former part which is developed by my partners, the robot will go and the switch out is gripper and arrive the desired position of the valve. Then the gripper will close and start to do the manipulation.
So right now we are in the middle of the arena that we are going to test to make the task. Our task is just it's allowed to turn a valve using a robotic arm and mapping with a drone and a Unit3 Go. And that will be it for today. Please stay tuned and subscribe to the channel for you to have more details about our research and our training school.